Hey everyone, here's our math problem for today. This is a requested math video. Let's say we are given this equation x to the sixth minus x cubed equals 2. X is an element of the set of real numbers. What is the value of x? You can pause the video and see if you can solve this math problem. Now let's solve this problem together. This is a 6th degree equation, and we know that solving a 6th degree equation is not that easy. Based on the fundamental theorems of algebra, we can expect 6 complex roots in this equation. But we are only after the real solution to this equation. We disregard the imaginary roots. So let's begin by employing variable substitution. We simply try to simplify the equation into a lower degree equation by letting the variable a stand for x cubed, and thereby x to the sixth is equal to a squared. And that way, we can reduce this 6th degree equation into a quadratic equation because x to the sixth is a squared, x cubed is a. This is a quadratic equation, and let's write this in the standard quadratic form. Fortunately, this equation is factorable, so let's do the factoring. The factors of a squared are a times a. The factors of negative 2 are negative 2 and 1 because this is the combination that when added will result to the coefficient of the middle term. So a times 1 is a times negative 2 is negative 2a, a plus negative 2a is negative a, which is our middle term. So the factors of a squared minus a minus 2 are the quantity a minus 2 times the quantity a plus 1, and we copy the right side of this equation. From the zero product property, each of these factors whose product is equal to 0 can be equated to 0. So we have two equations here. Solving for a in the first equation, we add 2 to both sides of the equation to get a equals 2. And for the second equation, we subtract 1 from both sides of the equation to get a equals negative 1. But we said that a is equal to x cubed. So, if two quantities are equal to the same quantity, then those two quantities are equal. This means that for the first equation, x cubed is equal to 2, and for the second one, x cubed is equal to negative 1. Since we are after the real roots, then solving these are easier compared to when we are looking for the entire 6 complex roots. So, taking the cube root of both sides, we have x is equal to the cube root of 2. And taking the cube root of both sides of the equation, here, x is equal to the cube root of negative 1. Since the index is odd, there's no problem having a negative radicand. Still, this is a real number. So, taking the cube root of negative 1, that is negative 1. To check if our answer is correct, let's substitute the cube root of 2 to the given equation. So replace x with cube root of 2, replace x with cube root of 2. Simplifying this is equal to 2 raised to 6 over 3 or 2 squared. Here the index and the exponent becomes 3 over 3 or 1, so we have 2. For its simplified form, the right side is equal to 2. 2 squared is 4, so 4 minus 2 is indeed equal to 2. So, the first root is correct. For the second root, replace x with negative 1. So we have negative 1 raised to the 6 minus negative 1 cubed equals 2. Raising negative 1 to an even exponent resulted to positive 1. Raising negative 1 to an odd exponent resulted to negative 1. Simplifying, we have minus of a negative number that becomes addition. So 1 plus 1 equals 2, and this is also correct. So it's verified that both x equals the cube root of 2 and x equals negative 1 are the two real roots of this given 6th degree equation. The other 4 roots are imaginary roots, and we are not after those imaginary roots. We want only the real roots. So this problem is now solved.